Extreme wireless installations can be monitored from Management Center, allowing administrators to review the health of wireless access points and controllers, as well as monitor the connectivity of clients using the wireless network. In addition, mapping capabilities in Management Center can provide physical location information and signal coverage information to the administrator. Wireless floor plan maps can be created to display AP placement and coverage. The floor plans also provide wall density information that is used to help determine the degradation of signal strength from the wireless radio as it passes through the walls. This information is also used to help define the probable distance of a client from a given AP. If an Ekahau site survey was performed and saved prior to map creation, the resulting Ekahau maps can be imported into wireless floor plan maps. If multiple maps were created in Ekahau, all the maps are combined into a single zip file when imported. Each Ekahau map is recreated as an individual map. When creating a floor plan map, multiple properties need to be set in order to allow for the accurate reporting of signal strength and client location. These properties include open spaces, office cubicles, dry walls, or brick walls. These maps can be imported utilizing PNG files, GIF files, or JPEG files. Additionally, a parent map can be completed. A parent map is a link to another map in Management Center Maps. This provides a hierarchical representation of maps. For instance, a geographic map of Building 1 can be created with a link to Building 1, Floor 1, wireless floor plan. Once a floor plan is created, the map scale should be set using the drawing tools. If the scale is not known, a helpful reference is that the standard doorway is typically 3 feet wide. Once the scale is set, the interior and exterior walls should be defined. The drawing tools can be used to specify wall types, thickness, and materials. For instance, a wall can be drawn that is made from drywall and then connected to glass. The different material types provide critical information for reporting wireless signal strength. After the walls are drawn, APs are added to the map in their appropriate areas. Lastly, the AP orientation needs to be set to wall-mounted or ceiling-mounted. Once this information is completed, the wireless map is complete. Within a wireless floor plan map, a physical area can be drawn that can be used by Extreme Control to apply different levels of access. This is similar to a geofence, where when a client enters a location, a different level of access can be granted. For example, in a stadium, a VIP area can be drawn that will grant a client a higher class of service than the standard user. Within an area, up to 16 sub-areas can be defined per floor plan. When creating an area, the depth parameter is used as a unique identifier. In the event a client is situated in a location shared by 2 areas, the client will be displayed in the area with the higher depth value. For example, in this picture, within the working area exists 2 other areas, developers area and executive area. Since the area depth of the latter 2 areas are higher values, the wireless user will be assigned access built for those specific locations when entering an area. Client location is determined by triangulation. Once access points are added to a custom floor plan and saved, a copy of the floor plan is sent to each controller in the deployment. The location engine, which must be enabled to support this feature, incorporates information defined in the floor plan data and signal information from the client's contact with APs in order to calculate a client's precise location. Client information from within a short time frame must be reported by at least 3 APs in order to determine a client's triangulated location. Location accuracy can be enhanced with the addition of access points configured in Guardian mode. When accessing the location's maps for a particular client, a colored distribution of location confidence is shown on the map, with black being the highest confidence, red being medium, and yellow being the lowest confidence. If the location is based on only one access point, the map displays probabilities for the location, but with a few differences. The location confidence distribution area is larger and generally displayed in a circular pattern. If there is insufficient data to provide triangulated results, the map displays the AP in the center with a circle showing the possible area where the client may be located based on the client's received signal strength. After a floor plan is finished and saved, the map is ready to display wireless coverage information. The maps can be used to present signal strength, channel coverage, data rate, and location readiness. These representations can also be displayed by desired band, 2.4 GHz or 5 GHz, and particular channel or specific access point. Real Capture allows real-time collection of access point traffic for troubleshooting and problem resolution. Real Capture collects traces on the AP wireless or wired interface and transmits the traces to Wireshark installation running on a local client. This functionality supports all Wireshark features, including filters and I/O graphs. It allows Wireshark to capture wireless traffic as if it were running directly on the AP, providing visibility into network connectivity and performance. This feature is especially useful for remote environments where physical access is limited. Enabling a real capture can be accomplished via a right-click on an AP in the floor plan map. Upon right-clicking an AP, a message appears to show that real capture has started and provides a CLI command on the host system where Wireshark is installed to launch Wireshark against the AP and view the captured traffic. Interface Wi-Fi 0 will display all the airframes, including beacon probes, management frames, and data, on the 5 GHz radio, while interface Wi-Fi 1 will focus on the 2.4 GHz radio. Taking a trace on interface ETH0 will show all wired packets that traverse the access point. Extreme